Hey guys, Cliff the Lazy Geek here and welcome back to the channel. I have here the new version of the ZWO AM5, the ZWO AM5N. I assume N stands for new. And if you haven't watched it already, I have done an unboxing of that ZWO AM5N, and I'll put the link up above and down in the video description if you're interested. But today we're gonna do the actual test of the mount. I'll be testing multiple things, but you can see here the main test setup that I'll be using, which is my dual scope. So we have two Newtonian telescopes on top of this mount, and the total weight is around 14 kilograms, although some of the weight around here falls below the axis of rotation. So it actually helps us. It kind of acts as a counterweight, but that's not a lot. So because the AM5N is rated to 15 kilograms without counterweight, and we do not have a counterweight installed, then we are basically at the limit. We're not above the limit of the mount, so we'll be testing it at the limit. And depending on the results, I might also test it like at a much lower weight of payload just to see the two extremes. But if the results with this are actually already really good, then I probably won't bother with this. Now, in terms of this setup, I want it to be like as precise as possible. So I am using the cameras here that have a 585 sensor. So the sensor pixel size is 2.9 microns. So we can see if there is like star shapes that are having issues. And I'll be taking 5-minute exposures with them. The guiding will be done via an off-axis guider. So we have access to the full 580 millimeters of focal length of the telescope to check. I've already done a polar alignment with this mount the previous night, and I've also tracked near the celestial equator where guiding is the hardest, and also across multiple bright stars in the sky to make sure that there was no high frequency movement of the star, but there was no such thing. The stars have looked really stable. So I already have some thoughts about the new polar alignment mechanism. In particular, there are no longer any azimuth locks. It's all based on tension within the base of the mount. And the altitude locks and adjustment mechanism, I'm not sure if it's changed or not, but it felt really, really smooth. And I did the polar alignment on purpose twice in a row, and it was overall a pleasure. What I did is in terms of the azimuth alignment, because there are no locks to lock it with, and it just like stays in place without me having to do anything. There was no longer that bumping the mount off polar alignments once I was done and locking the knobs. So that's a really, really good thing. And I can say the same thing actually about the altitude adjustment. I adjusted the altitude with the locking knobs already somewhat snug, as I usually do for this type of mount, just to be sure. And once I actually locked them in place at the end of the polar alignment, I saw maybe 1 or 2 arc minutes difference. So something that, in my opinion, is very acceptable. It's actually quite close to the Warp Astron WD-20 mount that I normally use. So it was actually really good first impression there. Now, I will say something about this is that I am not using the ZWO setup to perform this test. And you may be wondering why. This is because I'm using a dual telescope. So normally, at home position, the saddle together with the telescope would be pointing north, which is this direction for me, or south if you're in the southern hemisphere. And because this mount has a homing sensor, it knows where its home position pointing north or south is. When I have a dual scope setup, because everything is basically rotated 90 degrees, the home position suddenly would put both of those telescopes actually pointing towards this direction, so towards the west, which is not a good home position for me. So I wanted to make sure that I had the home position properly going towards the northern direction. But because of multiple things, it wasn't possible with this saddle. The reason being that when I tried to remove the saddle and just rotate it 90 degrees, that's all I need to do to support a dual scope, there's actually 2 little knobs there, like those 2 little thingies there, that fit into grooves that are only on the side of the mount that is pointing north. So it's not possible to take this saddle and then put it 90 degrees without it floating because of those 2 little tiny thingies there. So that was a bit unfortunate. I understand why they did that, but I wish I could just shave those things off so I could just use the saddle as is. So instead of that, I actually took the saddle off of my Warp Astron WD-20 and I put it on top, but that also presented its own issues because if you've watched my previous video, we now have in-saddle cabling. I have USB-C and I have the DC 12 volt output there. But the design there is actually pretty good. If we look to the back of the saddle, there's this little metal plate, or actually plastic maybe, that is held in place by two Phillips screws. And underneath there are plugs for the wiring. But by removing the two screws, I can easily take that little cover off, and you can see we have two white plugs that are easy to remove the connections from and place them back in. So it's actually, you don't have to use this particular saddle, you can change it for another saddle, and the cabling is easily removable without having to cut anything. The problem is that the cabling does take space, so I had to be careful when I placed my Warp Astron saddle in there, that I wasn't cutting off the cables or having them stuck in between the saddle and the mount head. So that was a bit of a stressful situation, but I did manage in the end. There's also one of my Patreon supporters that kindly informed me that there was some discussion about, like, if we have cabling in there, what happens if I keep rotating the declination axis 360 degrees, what's going to happen? Apparently there is no limitation, and I guess if you did it multiple times in a row, you could actually make those poor cables suffer, but you really would have to do that on purpose because obviously whenever you tell the mount to go home, it uses its homing sensor to just go back there. So that's a very much a niche scenario, but now you see how the cabling works and what is necessary to actually support a dual or even triple scope type of setup. As far as I can tell, unless we file off those little nubs or gear, we need to use another saddle. Now let's talk a bit about power, specifically the power output from the mount saddle, which is rated at 12 volt 3 amps, which a lot of people were worrying whether that was sufficient. And honestly, things about electricity, power, etc., that's not my forte, so I can't provide like a perfect answer to this. But I can give you this particular scenario that I'm using, where we have this Apertura battery here that I've reviewed on the channel before, by the way. I'll put links down in the description, that is connected via cable powering the mount. The mount itself is then routing power through the to the saddle, and the saddle is then connected to this mini PC on top of the telescope. The mini PC has an integrated DC splitter that is providing power to this camera here. This is a TopeTech full frame camera, and it is currently running at 95% power because I've set a pretty aggressive power target on this. So this is using quite a bit of power. The dew heater is also on at level 2 out of 4. At the same time, we are taking exposures, 5-second exposures with the camera in a loop, and I've been slewing the mount around at maximum speed to see what happens. So we have the PC running Nina, taking 5-second exposures each time, stretching the exposures and trying to find stars in them, so there's a bit of CPU power going on, and we are moving the mount around at the same time, and it seems to be working flawlessly. So in terms of power, at least for rigs like this, I think it's going to work fine. The accessories like the guide camera is also, by the way, I forgot to say, PHD2 is also connected to the guide camera and is taking exposures on a loop. The focuser wasn't used during this test, but it's just a USB powered focuser, so I don't think it takes that much power, and I would assume a filter wheel would be similar. So unless you have like a really heavy focusing train that requires 12 volt power, this is probably pretty representative of a lot of equipment that we have, and it's working with the PC that I assume is using far more power than something like the ASI Air. I mean, correct me if I'm wrong, again, this is not my forte. This is only the specific scenario, and it seems to be working pretty well as far as I can tell for now. I will also say from quickly like slewing the mount around, etc., it had no issues whatsoever. The slews are extremely fast, just like before. Centering targets was a pleasure. There was no issues whatsoever with the mount up to now, just slewing it across the sky. So tonight we're going to do actual guiding tests. I will likely point these telescopes to M16 because it's so close to the celestial equator where guiding is the most difficult, and we'll have a look at the results. And I also test the power output with the setup with the Red Cat that I just showed and tell you about the results. Before we go inside to look at the results, you may want to go and like the video. It takes a second. It really helps the channel out. And while you're going there, you may consider leaving a comment. Tell me, how do you think this mount will perform with this huge payload on top? And let me know if there's anything else you'd like me to check out about the mount. At the same time, if you're new to the channel, you may want to consider subscribing if you like this kind of honest equipment review and other stuff about astrophotography. In which case, welcome to the channel. And if you want to support me more directly, if you use any of the links that I have in the video description, you'll be helping me out a little bit at no cost to you. If you want to help more directly, you can join the channel as a member using the join button next to the subscribe button, or you can join my Patreon as a member. It absolutely makes the channel possible. As always, I thank you so much, guys. This would not be possible without you. I am hoping, by the way, to go full-time at some point this year, and this is thanks to you guys and your support. Oh, and I haven't mentioned it in the video. I want to mention that I got this mount from Agena Astro. Oh, and I didn't mention it in the video yet. I want to mention that I got this mount initially on loan from Agena Astro for purposes of the review. In the end, I'm apparently getting to keep it for free. So whether that's a good thing or a bad thing, you'll know in the rest of the video, depending on the results. But just so you know, that means that effectively, I'm being compensated for this review, even though it is not by ZW the maker, by Agena Astro, the astrophotography store, which, you know, in my honest opinion, is actually really good. And I've always had good experiences with them. I really like them, and I've only heard positive things about them. Anyway, enough said, let's go inside and look at the results. Okay, and now I've had the opportunity to use the AM5 across multiple nights, both with the Frankenscope dual scope setup, which pushes the mount to its limit in terms of payload, and on the other side of the scale with the Red Cat setup, which is light feather weight for the mount. And I have all of the results, including the tracking. So we'll be able to see how well the tracking did. And I also did a lot more polar alignment while doing tests all over the place. And I've also been able to basically see if the power on the Red Cat rig actually held from the saddle. All of this coming up. And let's start from the results of the first night of imaging that I did with the Frankenscope on top of the AM5N. This is basically the result, what I was seeing throughout the night. We have two samples, actually this one and that one, that I think are very significant. You can see one is at 0.49 arc seconds and the other is at 0.55 arc seconds. This is with an off-axis guider using my main scope as the imaging scope. This is excellent. I've rarely seen such good guiding in Tokyo, and even my WD-20 mount with the Frankenscope on top, I don't believe it manages such good guiding usually. So I am actually extremely impressed by what I'm seeing here with the AM5. We can have a quick look, by the way, at the frequency analysis, where we can see the main frequency is at 280 to 290 seconds. That remains in the guided out RA output. So probably a way to make this better would be to use predictive PEC from PhD2 with a setting of maybe 280 or 290 seconds as the periods. And then we have another little peak here at 62 seconds. So there's two peaks there. There's this one as well that is roughly around 1,100 seconds, but this one is fully guided out or almost fully guided out. If we look at the raw RA for this amount, you can see the RA is basically exactly as promised by the mount graph that came with the mount, which is this thing here. So this is pretty much in line with what I'm seeing, and we're seeing like from plus 7 arc seconds to minus 7.5 arc seconds without, with the guiding corrections removed effectively. This is very good. This is with the Frankenscope. This is with the mount pushed to its upper limit without counterweight, and we're getting excellent results. How about the mount with the Red Cat? I obviously would not expect it to perform any worse. And here is how it looks like with the Red Cat. Note that I had to exclude this little area here because that's when I was walking around on the rooftop balcony right next to the mount that was imaging, and my rooftop balcony is just a slab of wood. So obviously I have to remove this kind of thing from the test, but you can see 0.44 arc seconds guiding. It's pretty much the same thing, slightly lower than we saw earlier. So yeah, it's guiding better with the featherweight Red Cat on top, but not that much better. It's impressive. I was very impressed. I am very impressed by the mount. So the tracking performance looks to be good. In terms of the final results, this is with the Newtonian 5 minutes exposure guided, and I checked multiple of my 5-minute exposures. They're all the same. They're consistently the same. We get basically pinpoint stars, so that's also quite good. I was also doing multiple times polar alignment because I moved the mount around, I moved scopes between the mount. I mean, I've done a lot of stuff, so I probably did 10 times in a row polar alignment, so I could see when I tighten those altitude adjustment knobs, how much of a bump there is. Initially, when I first did it, I saw maybe 1 to 2 arc minutes. I don't know, maybe I got better at it, but now when I tighten the mount for several times in a row, I saw only around 30 seconds, 30 arc seconds, even less sometimes, of a bump in the polar alignment. And then in azimuth, there's no locks, so there's no bump at all. So yeah, polar alignment was also a pleasure, not quite at the level of the EM31 Pro, but definitely at the level of the WD20, which is also confusing to me because the polar alignment is really good on the M5N, and the tracking with the Frankenscope, the results that I got are actually better than my reference, which is the WD20. And I'm confused. I'm confused. This looks too good to be true at this stage. So, okay, what about the power? The power through the saddle with, this full frame power hungry camera together with the power hungry computer on top. No issues whatsoever. So I had a single cable from the battery to the mount, then everything else is in the saddle, and it just worked. And I had no issues whatsoever. The cooling worked throughout like no problem at all. Okay, so what's bad about this mount? Okay, because I have to find some bad things. I'm a bit annoyed there because it's really, really good. And yeah, I mean, I don't know what to do because, yeah, bad stuff. The wiring inside the mount is great for, if you're using it vanilla, but if you're going to use it with a different saddle, you need to make sure that the other saddle has a round kind of shape around its center so that it can host those cables that need to be hosted there. And if you're going to use a dual scope Frankenscope on top of that mount, you need to rotate the saddle 90 degrees, and the vanilla saddle with those little pins that it has on it cannot do that. So you have to provide your own saddle. That is honestly the only negative that at this stage I've found with the mount. I don't know what other negative there is. The go-to works great as well. Slewing is fast. Plate solving and centering, like just syncing with the mount and centering, went without a hitch. The meridian flip as well. We had like an issue with the initial driver of the old AM5 where you could not tell the mount to track X seconds past meridian or X minutes or X degrees past meridian. And it's not new to this mount. The ASCOM driver has been updated since, and it's true both for the M5 and the M5N, but now you can set that up in the ASCOM driver. So I was actually able to image 10 minutes past the meridian before doing the flip. No problem whatsoever. So the only thing I can say is that I haven't tested how well the AM5N will do over a long period of time, because I've read reports from people saying that after a while, their original AM5, they needed to retension the belts inside. So they needed to open up the mount and actually retension the belts, which apparently is not such a simple operation. So there is that to keep in mind. This is not a problem you would have with something like the WD20, which uses direct drive. But wow, I am thoroughly impressed by the mount. And I've reviewed so many strain wave gear mounts on the channel recently, And I've recommended, I think the most up to now, the WD-20, despite like the software kind of peculiarities that come with using OnStep as the control software for it. But I feel like I need to change my recommendation, at least if you don't need the high payload capacity of the WD-20. At this stage, the AM5N looks like, yeah, it's excellent. It's been extremely painless to test. Nothing went wrong. Everything was doing well. Hopefully I'm not like knock on wood that it keeps going on like that, but it's very, very impressive. If I run into issues with the mount, I'll make sure to update you guys with a new video, but at this stage, it is very, very good. So if you're interested in getting this mount, again, I have all of the links down below. If Agena is out of stock, it probably makes sense to even like wait for it to be back in stock because it's really good, at least for me. Maybe my sample is excellent, I don't know, but wow for now. Anyway, that's it. That's all I have for today. Let me know down in the comments what you think about this. Am I missing something obvious? Should I find some other drawbacks to the mount? Let me know down in the comments. While you're at it, you can click that like button. It takes a second, maybe even a fraction of a second. It truly helps the channel out. And if you're new to the channel, you may want to consider subscribing. And if you want to support me at no cost to you, use the links that I have in the description to buy anything if you're planning on buying anything from Agena. It helps me out at no cost to you. And if you want to help even more directly, you can join my Patreon as a member or the channel, the YouTube channel as a member using the join button next to the subscribe button. This video is likely 20 minutes long or more. Therefore, I will have the list of my Patreons at the end of this video. And as always, again, thank you so much. But you know, everyone who is watching, thank you so much for watching. I hope this was an interesting video. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.